2.
2.
That's why I can use this interval notation, because interval notation assumes that you mean everything in between those. Cool. And the range would be from what to what?
From -3.
Because the first place, I don't see them in -4. First place to see is -3
Yeah.
up to 3. Of course, it doesn't have to be. I could have made this higher, and they don't have to be like symmetric like that, right? But that's what I see. I see it goes from -3, that's the lowest output, to 3, that's the highest output. And if any musicians out there, you ever seen an oscilloscope, you ever did like a tuning fork, and you see that's the wave. That's what I was saying. It could be some kind of a wave thing. Yep. Cool. If you haven't, okay. That's the way we look.
So number 22, we write it like this.
Yes.
Not as an equation, -2.
Yeah, the book sometimes does this.
Yeah.
That's the same as that, right?
Oh, that's the same.
Personally, I like that better. It's just quicker to do.
Right.
But if you'd rather do it this way, that's perfectly fine. Which you understand that. Because I think the book explains it using that. But interval notation, that's what it's made for, to make it really quick. Okay. So if you want to write it like that, I love it. How would you write this one then?
-3 less than or equal to 1
X.
x. No,
Y.
Y. Range, right?
Y.
Didn't have to worry about that here?
Yeah.
No.
No, see, that's why I like
Yeah,
that.
Y.
Let's equal to.
So when X for domain, Y for range. You better be
Yeah.
careful. Okay.
So
That's why I'd rather just do it
that's
that way.
interval, and what's that one?
Doesn't it go into some sort of
That's interval
parentheses?
notation, that's just inequality notation.
Okay.
Doesn't it go like X such that, or no? That's
No,
not
it's
part of that.
extra crap that says the same thing.
Okay.
Yeah. Set builder, we don't need.
Okay.
All right. Blah, 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 blah.
So 23, we would write like the domain will be,
Yeah, I like 23. Actually, let me make one like 23 that shows you one thing I want to show you before we get to the next section.
the range will be 4.
What's the domain and the range?
All the numbers, the domain.
The main, the main would be -1 to 3, and the
No,
Zero.
all the numbers.
4, 0.
Are they? Does 1.5 go somewhere?
No.
So you can't use interval notation here, can
No,
you?
it's written a line.
Negative
It's a line.
1, 2, and 3.
What's the domain?
Negative 1,
-1,
1 into
3.
1,
What's
2,
here?
and 3. 0.
0.
1 and 2 and 3.
That's the domain. You guys see the difference? Why was I allowed to use this notation here? Because it's filled in. What does this mean? Every number from -2 to 2. So if you say that here, if you say this, every number from -1 to 3, are you right? You're telling me I can use this number. It doesn't go anywhere, does it?
Points?
Yes, if they're not connected, you have to be more specific.
It's
You can't use interval notation, you have to just give me a list.
So the range is just 4?
Yeah, what's the range?
Negative 4.
4.
4.
What's the only output?
4.
Yeah, for an input in -1, the output is 4. 4, right? So my range would be 4.
It means y
But
is
here in
always
the
4.
exercise, you plot like a line.
I love it. I just wanted to do
For the
this. I want to do this just to show you. Now, if it would have been this, from -1 to, I can't remember, did it go to 3?
1, 2, 0, 3.
If it would have been that, what would have been different? The range would still be
4.
4. It'd still be 4. But how can I write the domain now, though?
Or -3.
Shortened form.
I can say everything from -1 to 3. Why can I say that? Because now everything,
Yeah.
now everything is in there, right?
Oh.
Here, is everything in there?
No.
Oh shit, I better just identify the specific points then, right? So whenever you have points on a graph, it's going to look like this. If you have it connected, do you want to list every point then? How many would there be? Infinite number. Screw that. Let me just write this. Everything between this and this, right? The range would, of course, like we said, still be just 4. Because that's all that comes out.
It means y is always 4.
Means y is always 4, exactly. In fact, that would be the equation of the line. If we made a line, it'd be y equals 4. Okay. So guys, I'm very excited about this whole thing. I definitely want to get to 3.6 because 3.5 is all these ideas, and they're not really difficult.
The book say, the answer of the book is for the domain Mine
Oh, I
is
didn't draw
five.
mine the same way. I started, they went down to -5. It's the same idea. Same idea. I just didn't make mine the same way. Okay. Section 3.6 is a much more sink your teeth into it type section. What I mean by that is you actually calculate things in section 3.6 instead of applying definitions. Has anybody in here not seen, and don't be ashamed to say this, have you never seen that? Okay, a few guys. Okay, a few more guys.
Actually,
Okay, a few more guys. So let me give you a little motivation as to what the hell that is and why they even created it. So let's say I've got one line here. When you plug in a 1, what do you get for y?
8.
8. When x is 1, that took a while to write. When x is 2, what do you get for y?
9.
9.
No.
Does that why, I don't want to write all the crap out. I'd much rather say, so instead, people hate this, and I really want to get to the bottom of the reason people hate this notation is because you think too much about this. This replaces y. You read this as f of x. That gives you a place to put your input, and this is where your output is. This is not f times x. Right?
Looks like
It's
it.
not multiplication. I know it looks like it.
So,
But this is huge because this is what the rest of mathematics uses as notation to make something really quick. Because later you learn all these other functions. You learn like a trig function. I want sine of something. Or the log of something. That's the same as this f of something. That's the same idea. Right? So this idea is important.
and that's the same thing as saying y equals x plus 7?
Same thing. But now look what happens. If x is 1, so I want to make x 1, don't I? So f of 1 is 1 plus 7 is 8. So instead of having to tell people, oh, I made x 1 and I got y equals 8, I can contain it all in the same line.
Yeah.
What is the function when x is 1?
8.
It's 8. What point does that function go through? 1 comma 8. I can see it. That's one little thing, right? And by itself, that's not really like, oh, thank God they did that, right? The other piece of this that I can talk about right now, is everybody cool with this idea? What about f of -2? What would I do?
Negative was 5.
So what did I make x?
-2.
And what does it do to x? It adds 7 to it, right?
Yeah.
So you guys see the basic idea of functions is substitution. Just whatever they put there, what am I going to do with it? Put it for the x.
I have a question.
Yeah.
So instead of y, you're using, I guess, f of x would open it up for more options or plugins?
Options and plugins. I can see what I plugged in.
Right,
I don't have to keep track of it separately. I can see it.
right.
And it also gives me the option to have more than one. If I wanted to describe another line,
Right.
I'd have to do like y1 and y2, and that gets confusing because then my brain thinks slope and y2 minus y1 and no, right? So now I can do this. And you're all like, that's nice for you, Jeff, but now I can do something like this. And here's where I really want to focus on this. Because everybody gets so confused with functions, and they're so stupid important for all of mathematics, and they're not that difficult. It's just different from what we're used to. But can you see the usefulness right here? What people always do right here, I get f of -2 is 5, and I always get somebody to do this, divide by -2. You can't do that. That does not mean f times -2. This is one thing. It means what's the function at -2? It's 5. So you can't divide by -2. Do you guys see that?
Yeah.
Maybe. Sort of like if I add square root of 9 equals x. Okay, or let's do this. Let's do it the other way. Square root of x equals 9. Let me divide by the square root symbol. Yeah. That doesn't make any damn sense, does it? I can't do that. It's the same exact thing trying to divide by f or divide by f. You can't. Okay. But now I can do something like this. F of x is x squared minus 2. G of x is the absolute value of 3 minus 2x. Oh shit, Jeff, when are you gonna stop? Okay, that's good. Instead of having y equals y equals y equals, now I can identify each one very quickly. If I want to know what g is when x is 7, what would I write down to have somebody figure that out for me? Well, x equals 7, but I want to look at the g function. G of 7. There's no question. Which one do I use?
G.
G, because it says stupid G. Right?
Well, where you bring the 7 from G?
Keep going.
Because what could x be? Anything. Now, of course, they're going to give you specific questions, just like I just did. So the book is going to say G of 7. Then you got to look up and say, oh crap, what was G? Let me throw a 7 in. This is just substitution. Don't make any more out of it.
Okay.
It's just that now it's a much quicker way to identify where to substitute. Oh, I got 3 functions. Where do I put 7? Well, there's no question. I put in the stupid G function. They said G. Right? So how would I do that? What would it be?
It is 3 minus 14.
3 minus twice 7.
11.
Come on, Jeff. And then 3 minus 14.
11.
It's negative 11. And the answer by that,
11.
11. How we do?
Yeah.
So it's just substitution. What about, what's h of negative 1? Take a second to figure that out. H of negative 1.
Minus 1 plus
No,
3.
3.
No.
Oh, that sucks. Hold on.
I see my competitor sheet.
Negative 5.
Negative 5.
Negative 5. And I want to make sure you guys can handle it. If I have more than one x, I don't care. H of something is something cubed plus 4 times something. So what's h of negative 1?
Negative 1.
Negative 1 cubed. Plug a negative 1 in. Plus 4 times negative 1.
Negative 5.
Of course, negative 1 cubed. 3 negatives, 2 cancel, you have 1 left, so it's still negative 1. Right? Negative 1. 4 times negative 1 is minus 4. There's your minus 5. Right? So what point does the h function go through that we know of? What point? Negative 1, negative 5.
Yeah.
What points does the g function go through?
7, 11.
7, 11.
Well, thank heaven.
9 points.
Yeah.
Minus 1.
What about this guy?
Oh,
So you know I'm going to have to throw you some kind of curveball eventually. F of, oh. What's f of w?
Just plug W in, right?
Yes. Don't make any more out of it. That's exactly the way you should say it. Just plug a stupid w in, Jeff. What the hell? But that always trips people up. If f of x is x squared minus 2, f of w is
W.
w squared minus 2.
W squared minus, that's the answer? Yeah.
That's the answer.
Okay.
Now that by itself is like, why is that useful? Well, because if I want this to be like a function of width, right? Like maybe, bless you.
Thank you.
Some function of width, I want that to be a w, so that I know it's a width that I want to throw in there, right? And that's actually the last thing I want to point out about these.
You know what, I'm saying something here, I'm just confusing me on page 254 at the very top. Like try 28 and where the,
Oh yeah, well that's, I'm getting there.
oh, okay.
Yeah, yeah.
Oh, okay.
Okay. Like for example, if I have this, what's the perimeter of that going to be?
That's gonna be 2x plus 1 equals 2x.
Plus x.
I mean, plus,
plus 1 plus
yeah, so 2x plus 1.
Double. Yeah.
So you made it halfway,
Yep,
Yeah. Double of all of these.
plus 2x plus 1
yeah, plus x.
plus x. Now look what I can call that. Am I telling you that what it is? Did I tell you what the perimeter is? No, but I can just say the perimeter of x. And now all somebody has to do is tell me what x is, and I can throw it in there. See, now the functional notation, the last thing it kind of does for us is it gives me the option to make this make physical sense. If it's a perimeter, I can say perimeter of x, p of x, so that I know it's a perimeter function. What's the area of this?
X times 2x
Perimeter.
plus 1.
Yeah, 11, right? Length times width.
Yeah.
So this would be x times 2x plus 1.